Optical path length lambda mu is equal to lambda upon u, t is equal to 2 pi upon lambda in bracket ut. Optical path length t here, geometrical path length. Distance of the CM from point O, y is equal to d upon small d in bracket mu minus 1 t. For maxima y in bracket from point O, n lambda d upon small d plus capital D upon small d in bracket mu minus 1 into t. For minima y in from point O in bracket 2n plus 1 lambda upon 2 capital D upon small d plus capital D upon small d in bracket u minus 1 t. Angular positions of minima, secondary, maxima. For minima, theta is equal to n lambda upon a. For maxima, theta is equal to in bracket 2n plus 1 lambda upon 2a. Positions of minima and secondary maxima from CM. Y is equal to n lambda d upon a. Y is equal to in bracket 2n plus 1 lambda d upon a. Linear width of minima and secondary maxima. Linear width, it is distance between two consecutive minima and secondary maxima. B is equal to lambda d upon a. Linear width and angular width of central maxima. B is equal to 2 lambda d upon a. Law of Malus. I transmitted is equal to I naught cos square theta. I naught intensity of the plane polarized light PPL. Theta angle between transmissions axis of polarizers 1 and polarizers 2. Method of polarizations. Polarizations of reflections R is equal to 90 minus IP. Snell's law. Sin LP upon cos LP is equal to tan IP is equal to N2 upon N1. Derivation law. If N1 is equal to air, then tan IP is equal to N2. Polarizations by the scattering YXZ PPL scattered